Hi. So as I'm Steve Francia, work for 10gen, and that's the company behind MongoDB. And I'd just like to say, as part of this webcast, there's hundreds of people right now all connected through our computers, but we don't really have a touch point with each other outside of that chat window. And so one thing that I find is helpful is if we could just introduce ourselves, say where we're listening from. It's kind of amazing that we have people from all over the world simultaneously part of this conversation. And so one big touch point that I think helps is if we start by introducing ourselves. I'd also like to encourage you, if at any point throughout this webcast, if you have any questions, please just ask them at that moment. I'll see them, and if it's relevant to the topic, I'll cover it. I'll stop and go over them. If not, I'll save them for the end, but I'll get to every question that we have time for. And now I'll start. So I'm going to start with a fairly bold statement, a bold claim that web development, as we know it, is broken. And it's one of those things, it's sick, and we might not even notice that it's sick because it's always the way we've been doing it. And so I've come up with a list of symptoms that demonstrate that web development is broken. The first symptom is the ORM. And there's been controversy around these object relational mappers since they were first introduced, and it continues to today. You've got SQL, and that might surprise you to hear, but I'll go through and explain why I think that SQL is symptoms of a broken system. We've got agile development. A lot of people start in an agile way, but as a project continues over time, it becomes less and less agile to the point where it's rapidly unsustainable. We have overly complex architectures, and finally, Memcache. Memcache itself is a symptom of a broken system, and so. What I want to describe is the problem with SQL. Most people in our industry know SQL and we're familiar with it, but most people have forgotten the origins of SQL and what it was designed for. It was designed over 30 years ago to solve the problem of a database having an interface with a human. And so when the database was designed with SQL, the intent of it was to have a business would have these database operators, and they would send requests for data they wanted to these database operators, who would sit in front of a terminal and manually type in, using this structured query language, what information they wanted to retrieve. Then they would take that, they would print it out, and they would bring it over to the person who asked for the information. And so SQL itself was designed to have an individual person type into a computer terminal. SQL is designed for that problem. It's a human interface. It's not a computer interface. It's a human interface to a computer. And today, we've lost sight of that. Today's applications do not work that way. We don't give direct access to the database to humans anymore. In fact, I don't know any company that has humans typing SQL queries on production databases, and in most companies that would be grounds for dismissal. And so today we've built applications around them, and so we have applications talking to databases. It's computer-to-computer interaction, but we're still using this old query language that's designed for human interaction. And so that's one of the problems. The second problem that we have is that it's a problem of paradigms, and the big challenge here is that in our programming languages, we're programming in objects and arrays, but our database is rows, tables, and columns, and objects and arrays don't naturally fit with rows, tables, and columns. It requires you to think about things a completely different way, and so we think in one mindset for our programming and in a completely different mindset for our database. All right. If you're not convinced, let's take a look at your workflow. So we'll walk through what I think is actually a pretty common and generally recognized as a good workflow. So when you write a program, you start with an idea. You've got a product that needs to be built. And so with that, you get very excited and you go and you want to start building it, and what do you do first? You have to start with the data model, because we've learned through our own experience that if you start with the product and the interface first, that the data model will have to change so many times it's too hard. So you have to start with the data model, and so we begin doing schema design. We use these ERD programs to be able to generate these complex schemas. We approach them in an almost omniscient way, thinking that we can model out everything that will need to happen for the lifetime of our application. And at this point, we're not even sure what we're building yet. We just have an idea. But we need to start with the model because you have to lay the foundation. And so this is a flaw in our workflow, because we need to build things as a foundation that's hard to change without a full understanding of what we're actually needing to build. But once we've laid our foundation, we then add controller and view code. And once development is finished with our first version of our product, we ship it. And this is the high point of development. This is when we throw big parties and cheer, because we have finally gotten to the point where we're able to have our idea out in the wild and let other people use it. And so when the product goes live, it's not complete. We want to add more features. And so we begin that process. Now, how do we start that process? Back to editing the model. Because we need to change our data model to adjust to the features that we want to add, to how our users are using our product. Except now when we adjust the model, it has complications to it. We have to worry about all the data that's in the model and all the users. And so along with that comes some undesirable consequences. We've got alter table statements. We've got to worry about data migration and porting it from one format to another. And we have to worry about database lock-in, because when we're running these alter tables and these data migrations, we can't have our users accessing the database when it's in this transitionary state. And so we need to have downtime when we're doing this. And so every new feature needs to be validated by this extra cost. Whenever we're adding a feature, in the back of our mind, we're always thinking, how will this impact what we're doing? How big of a cost is associated with this when we have to change the data model? And so once we've done this and we've gone through that painful process, then we have to adjust controllers, view, and ship. And acknowledging that shipping is more expensive here too, because we have to deal with all of these operational challenges when we ship it. Now, over time, the site begins to pick up traction, and we need to add cache. We realize that at this point, we're starting to outgrow our database, and the best way to scale a SQL database, we found, is to add memcache and put more caching layers in front of it. Now, important thing to remember about memcache is that memcache itself doesn't talk directly to the database. And so we've got this caching system and a database system, but the two of them don't talk to each other, so we have to do it. So we have to write all the logic in our application to be able to manage the synchronization between these two external systems. And so we write these caching rules throughout our entire code, and they're responsible for saving and expiring cache. Now we need to, whenever we create new data, we need to write it into two places. And we need to update two places, and we often need to query two places. And so if you look at the interaction of a modern web app, our application writes in objects. Those objects themselves need to translate into rows. And often there's multiple rows for each object that we have, often with multiple tables associated with them. Those rows then go into SQL. And then we separately create key value pairs, key value stores for our memcache, because memcache speaks in key values, MySQL speaks in rows and tables, and our application speaks in objects. And so we now, you might see this and think this is very familiar. This is how I've been building web apps for the last 5 to 10 years. And what we recognize is, due to the extensive data model layer, agility becomes unattainable. Because whenever we have to change something in the schema, we actually have to change it in 3 different schemas. We have to change it in our objects, we have to change it in the SQL relational schema, and we have to change it in memcache. And often, a given point of data would be stored in lots of different places in memcache, and often have impact multiple changes with the SQL schema. And so what ends up happening is that product development is constrained by data storage. And for those people who come into it from a product mindset, how often do you hear, oh, we can't make that change because it's too expensive. We have to change the database and we can't do it. As a former CTO, I've given that answer multiple times, and it never felt good to give that answer. And I've always thought in the back of my mind, there must be a better way than doing this. Right? This feels very broken. And so now we'll introduce MongoDB and PHP. MongoDB is a better way of doing this. MongoDB, and we'll walk through why and how MongoDB works. So with MongoDB, the purpose of this is to provide an introduction. And so we'll cover some of the basics of getting started with MongoDB and PHP, and then discuss the why this is a solution to the broken web development that we've been experiencing and always known. And so, well, relational data made normalized data look like this, right? And this is a simple ERD diagram of a blog, right? You'll notice that everything is nice and separated and normalized, and you've got consistency. In a document database, it uses all the same business entities, but associates them differently. Well, you could have users and articles are completely separate because they're separate business objects, but tag is really just a property of article. It's a property of article that happens to have multiple values as part of it. Right? And in SQL, we don't have a way of storing multiple values, but in MongoDB we do. And so that just becomes a property, just like anything else. Category operates in a similar way. And comment here, you'll notice, comment has association and relationships with the user who is making those comments, but it's still actually a property of the article. And that's because every comment lives not abstractly, but as part of an article, or as part of a blog post. And so now I'll walk through getting started. And so for those of you who haven't used MongoDB before, I'll demonstrate how you'd begin using it with PHP. Now the first step is to install the PHP Driver, and this lets your PHP installation talk directly to MongoDB. It's as simple as peckle install Mongo, and then ensuring that the right line, this is one for Mac and Linux, a similar line would be for Windows, but would end with DLL, is added to your PHP INI file, right? And then restart Apache. So once we've done that, now PHP can access our MongoDB installation. And the first thing we're going to want to do is connect to MongoDB. And so with that, the process is you'll create a new Mongo object. This is a connection to the server. And so as here I've called it connection. With connection, you're going to select what database you want to connect to. In MongoDB, the term database is fairly analogous to what it is in SQL, meaning a slice of with permissions around it of your data set. And so you've got Mongo servers, and then inside of a server there's database, and inside of a database is collections. And you'll see on the bottom line here that we're connecting to a collection, a specific collection inside of that database. This is analogous to a table in SQL. Now, one thing to point out here is that the database, we have not done any schema design. We have not added any of these things before we started. We simply opened up our PHP and began typing this in, and we're going to run this. And as we run it, it will automatically create the blog database and the post collection inside of the blog database when we run this for the first time. And so if it doesn't exist, MongoDB will create it when it connects. And this is all part of the agile, flexible way that we do things with MongoDB. So now that we've connected and we've set up a collection object, the next thing we want to do is create a record. And so what we do is we go ahead and we're just going to use an array. We're going to create a normal PHP array with a series of keys and values. In PHP, we refer to it sometimes as an associative array, where we've got the keys and values. And each value itself could also contain an array. And it can contain either an array like a list with just single values, or it can contain an associative array with key values. And so this looks very normal to us. This is how we interact with it in our application. And so once we've defined this array, we simply call save on the post collection object, and it saves it. All right, so going through it, this looks very strange if you're coming in from a SQL background, but if you're coming in looking at how you interact with other parts of your other parts of in your programming, other APIs, this feels very familiar. Stepping into the next thing, once we've saved it, we're going to want to query it. We're going to want to find that record. And so MongoDB provides a few different ways. The simplest way is to use on the collection object, we're just going to call find one. And that will give us the latest inserted record, or the last inserted record in it. And you'll notice when we do that, what the response is it responds with a PHP array. And the PHP array looks very similar to the one that we saved it with. There's a few new fields in here, the one with a primary key field that's automatically created called _ID. But substantially, it looks the exact same as what we saved. MongoDB does not only speak in arrays, it also understands PHP objects. And so you can just as easily create an object and persist that object. Now, it will only persist the data in that object. It won't persist the methods. But any public variables it will be able to save. So it'll treat it in a similar way of how it treats an array. And this is a nice feature, as a lot of people are writing object-oriented programming today in PHP. It's nice to be able to do it, to use those natively without having to convert them. You'll notice here that we're using the insert rather than save method on the post collection. And save is just kind of a convenience method that will say, does this record exist already? If it does, I'm going to update it. If it doesn't exist already, I'm going to insert it. And so you can just as easily call insert or update, but save gives you the convenience of not needing to worry about if it exists or not already. And again, if there's any questions, feel free to ask, or if there's any comments that people want to make, please put those in the chat room, and I'll be happy to answer them. And so, as we mentioned, talking about updates, one of the unique properties of MongoDB, as for all of the NoSQL databases, is it gives the ability to do inline, in-place updates, and it does them with atomic transactions. And so what you see on your screen here is that we now have this blog record of a single article, and we want to add a new comment to it. Now, there's two ways we could do that. We could retrieve the entire article, modify, which would bring it to array into PHP. We'd modify that array and then save it. Now, there's problems that happen when two different processes want to do that simultaneously, because both of them will read it in and both of them will modify it, and whoever saves it last will overwrite the first save. And so if you look at, if they're staggered in that way, you're going to end up losing data. And this is the way that most NoSQL databases work, because they can't do this inline atomic operations. But MongoDB retains that property that SQL has, and gives you the ability to do these in-place updates. And so what you see here is what we're doing is it's a push operation. In MongoDB, we have these special operators that all start with a $, and I've listed a few of them here. And so what we're saying in this, to speak kind of in English, is what we're going to do is we're going to push onto the comments field a new entry. And that entry is in itself an array with these values. And this could happen by lots of different processes simultaneously, and it will work fine. They won't have any collisions, they won't have any data loss, and they will just all append to the end of that array. And so first what we do is, in MongoDB, our queries and our change and our updates are all done by passing arrays in. Our query field is always passed in an array that you want it to look like. It's an example. And so in MongoDB language, you're saying, find me a record or all records that match this array. And so the first parameter for update is that query portion. And you'll see we're saying, give me an array where, or give me any records where the ID that we're passing in equals the underscore ID field, right? And the second parameter here is the changes that we want to make. And so in this one, we're using this atomic operator push to do so. And what that results in is a nested document, which is another way of saying a nested array. And so what you have here is the ability to have keys, as we talked about earlier. You've got keys and values. Those values themselves can be a list of individual values, or they can themselves be a full array of keys and values, of fields and values. And we refer to them as nested documents in MongoDB terminology. And part of the reason for that is they're treated just like any other document, and that they're able to be queried on like other documents. And the next slide I have coming up will demonstrate some of that querying. So if you look at that nested array, you'll notice here the first thing we're doing is, as I described earlier, we're just saying, find me any record in the post collection where Roger is the author of it. And so that's the syntax here. It's very simple. I'm saying I present to you an array that looks like this. Find anything that matches. In our second example here, we're going to find any article in the post collection that Fred commented on. And so you'll notice we use dot notation. This is similar to JavaScript and how we're doing nested. So comments is the top level, and we don't want to search for comments. We actually want to search for comments author. So inside of the comments field, there's another array with fields, and one of those fields is author. And so I'm saying, find here any article that Fred commented on. And in the last one, we're doing something similar, except for I'm demonstrating here a regular expression. So MongoDB doesn't use like SQL does, but it instead just uses regular expressions, PCRE, the same ones that PHP uses. And so here what we're doing is we're saying, find me anything that starts with Fred. And of course, in our simple data set of 1, it will find all of these would return the exact same post. But demonstrating the different abilities. By the way, we haven't created any indexes on this yet. MongoDB supports indexes, and we'll talk about them in a minute, but it's important to recognize here that we're able to query our data in a very ad hoc way. We can query it any level deep without impacting performance, and we can query on any field without predefining any indexes. And this is a property retained from SQL to build these ad hoc queries. Now granted, if you don't have indexes on them, they won't run as fast as if they did, but you still have the ability to do so without indexing everything ahead of time. As I mentioned, we've got these atomic or different kinds of operators that do different things. Some of these in this example are for querying, like greater than. So it's $GT, which says, in the example below, it's saying, find me any field X where the value in it is greater than 4. And it will return it to you. Now you'll notice in the second example here that I'm using double quotes with the $GT. Don't do that. It doesn't work. In PHP, it'll try to evaluate that as an array, as a variable, and if you haven't set that variable ahead of time, you'll throw an error. Or worse, depending on what your error warning setting is, it could just evaluate it to null, and then it won't work right. And so it's important in PHP especially to be aware of that behavior and always use single ticks. So now I'm going to talk a little bit about indexing here. And so in MongoDB, indexing is very similar to relational indexing. We use B-tree indexes similar to MySQL, Postgres, and other relational databases. And so what we're doing here is we're saying we're using a collection object, and we're using the method ensure index, and we simply pass in an array of which fields we want to index. So the first example here is saying create a regular ascending index on the property age. And the second example here is demonstrating a compound index. So here we're creating an index on 3 fields. We're creating an index on name, date, and comments author. And we're doing the first 2 in descending order. And partly to, with dates, we're often querying more recent dates. And so it's helpful to have it in descending order because we want the more recent dates to be faster, because that's what we're querying on most of the time. And if there isn't a reason to do that, then it's always easiest to just create them with 1 in the ascending way. And so a couple things to talk about indexing while we're here is that in MongoDB we don't have schemas. It's a flexible schema. That means from one record to another, they might have the same field names and they might not have the same field names. In fact, they might not share any field names. And you might wonder, well, why are we grouping things into collections? And the answer is because of the indexes. The indexes, we're going to want to group like things in collections. And so you'd have a separate collection for users than you would for articles, because we're going to want to create indexes on them in different ways. Now, the way indexes work is that when you create an index, you can create a couple different kinds of indexes. You can create an index where a field is required. It must be created. You can also create an index where a field isn't required, which means some of your records might have that field and some of your records might not have that field. And it just works. MongoDB will automatically skip all documents if a query comes in looking for a field name on a field that doesn't exist. MongoDB will just skip the records that don't have it. And so it gives you a lot of flexibility as you're building your application to not have to worry about schema changes and be able to lazily migrate things. Right. I'm just looking through right now. A bunch of questions came in, and wow, a bunch of questions came in. I'm going to go through a little bit more through this section, and I think we'll pause and I'll read through these questions and try and answer some of them. And so this is a little bit more on indexing. It's also important to recognize in MongoDB that these aren't typed, and so in a given field in one document could be a string, and another document it could be an int. And MongoDB handles that very elegantly. If you're querying with an int, it'll only look for the ones that have ints. If you're querying with a string, it'll only look for the ones that have strings. And it doesn't matter that they're not the same. And so here what we've demonstrated is a few different indexes, including a new type of index that we'll briefly talk about, and demonstrate a query that would use those indexes. And so the first one, we're creating an index on a nested value, comments author, and then we're querying on that. And you saw these two, you've seen both of these examples in earlier slides. The second one, we're going to create an index on a top-level value, but itself is an array. So it's not the field name is tags, but the value is not a single value, it's a set of values. And so we're going to be able to create an index on that. Now what that does is it'll index every single one of the values inside of it. And it's easy to query on. We just say, show me every blog post that has tech as one of the tags. We don't have to tell it that tags is an array. MongoDB is smart enough to know that. It'll just find it. If it's one of the values, it'll automatically find it, which is a nice property. It even lets you do nice things like, a good example of this is, let's say you're creating a blog engine that initially was designed to only handle single authors. Now, all of a sudden, you've done this, your system's been running for a year, and now you've got a new initiative where rarely, but sometimes, they're going to have multiple authors on a post. Now, if you've modeled your database in a relational way, you think about how to approach that. That's not an easy thing to do. I'm going to have to take all the authors that are single field, I'm going to have to abstract them into their own table now, and I'm going to need to be able to migrate all these existing things. And you might tell yourself it's not worth it. In MongoDB, all you do is, for the ones that have multiple authors, you store them as an array, and the ones that have single authors, you keep them as a single value. And the queries are the same. If you're trying to find any blog post that Steve wrote, doesn't matter if he's a single author or a multiple author is one of the elements of array, it just works. So you won't need to modify your code, other than your display code a little bit to handle if multiple values come out, to put multiple values there. But it's a very, very small and unintrusive change when you have MongoDB as a backend, whereas if you're using a relational database, it's a very large change. It's one that's very costly and one you think twice about making. The last index in the example here is author location. Let's say this is a geographic location with longitude and latitude. MongoDB supports these geospatial indexes to be able to do queries against them. And these are special index type called 2D. And you can see the simple example there, and then we're going to query it for any author location that's near these two coordinates. And we won't go too much into that, but there's plenty of information both in the book as well as on the website of more on that. So there's a couple more things to touch on here. One is that in MongoDB, when you run a find, it doesn't return to you the data. What it returns is a cursor. And the cursor, as you iterate over access, it will lazily fetch the data. And so in this example, we're going to find anything where foo equals bar. And per se, it returns to us thousands of documents. It won't actually do anything at this point. And so you can send that cursor to your template layer, and maybe it's in a conditional. Sometimes you might display it, sometimes you might not display it. It won't actually execute and talk to the server until you try and access those values. So it's done completely lazily. And one of the nice features of that is that because it itself, until it's accessed, doesn't actually execute the query, it lets you do modifiers to it. Things like sorting it, skip, and limit. And these are three things that you'd probably want when you're paginating. Right? And so with MongoDB, pagination is very easy to do. You're able to easily just tail these methods off of the cursor, and as you can see in this example, string them together to do easy pagination. And so what you see here is an example of a rich document. One nice feature of MongoDB is you're able to store these really rich documents. This might be an example of a order. Right? In an order, you're going to have different line items. It's nice to be able to store them in the same order without moving to another table. You're going to have the address. Let's say it's the shipping address for the order. It's great to include them all together because it's really intended for them to be together, especially in the example of e-commerce. An order itself is a snapshot in time. And so you really want to access all of these things together and only as an order together. You're not looking at addresses abstractly from the order. You're only looking for an order, and you want to know about the address to send it to. You also see here you've got payment information, of course, in your databases. You'd encrypt that. I just made up a bunch of numbers. I probably should have made up something that's not even possible to be a credit card, but that's for another version of these slides. And then you'll see the subtotal. And in this example, what you're seeing here is a bunch of different things. You're seeing you're seeing nested documents in the line items, and you're seeing nested documents inside of a list, and you're seeing nested documents in the address and payment sections of this single document. Okay, so MongoDB has been enabling web developers since 2009. And so as we talked about at the beginning, there's this problem of web development that is broken. It's fundamentally just broken. And MongoDB has been enabling web developers to do things in a more elegant way. And so we'll touch on a few of those points here. In MongoDB, documents are analogous to arrays. Documents in the database become arrays in PHP, and arrays in PHP become documents in the database, and the two of them are fairly synonymous. There's no conversion necessary. MongoDB provides an elegant interface, and so that first one it does is it solves that paradigm problem, and that the way you interact with your database, the way your data is stored, is the exact same way you program it. You save things in the way you want to work with them in your programming language. MongoDB has an elegant interface. The interface feels like any other API interface that you use. It feels like you're still writing PHP. And so, this fixes another problem, the problem of SQL, the problem of if anyone was writing a new API today, who, by a show of hands, which we can't do in a webinar, and I'm not going to set up a poll, but just think to yourself, how many of you would actually write it where strings is the interface, and we'd need to parse these strings, and we'd write a language around it? I don't see a single hand up. Of course, it's a webinar, I can't see any of you, but none of your hands should be up, because that's not how we program things today. We use direct method calls, and we use defined interfaces, and we don't worry about parsing them. This is how people program interfaces for computers to talk to computers. And nice features happen here. When you want to do an update, that's a direct method call. There's no such thing as SQL injection, because there's no way to do things that you're not intending to do. When you create a delete, it's a delete method. There's no way to pass in user data that accidentally deletes or updates something. And so because we're using direct method calls, it's simpler, it feels natural in our programming language, and it avoids a lot of security problems that come as a result of it. In fact, the interface is so nice that Matthew Wirofini, who's the lead of the Zen Framework project, said it was the single best interface of any PHP extension. And so with MongoDB, you have a new workflow. You start the same way. You start with an idea, a product to be built. This is where you have all the excitement. Except in MongoDB, you continue with that excitement, because the next thing you do is you code it. You don't worry about the database. You start building what you're actually trying to build. You don't worry about building these giant schemas and trying to omnisciently think about things ahead of time, because the schema itself is empowering you to be able to just write your code. And as your code changes, the schema will adjust to it. You can easily add new features and enjoy effortless scalability without worrying about the database. And you'll be able to enjoy super fast reads and writes. And this feature, we'll talk about memcache. The reason I describe memcache as a broken part of the system, as a symptom of the broken system, is that memcache is designed to do one thing, and it does it pretty well. But what it does is it optimizes reads. By storing reads in memory, it optimizes them. But it does it at the expense of making writes a little bit more expensive, which in itself is kind of problematic, because SQL does relational databases do a reasonably good job of scaling reads. It's writes where they struggle to scale. And so memcache helps, and it helps a lot, but it helps on the part that we can kind of do pretty well on our own. But it doesn't help us all with scaling writes, and writes become more expensive when we're using memcache, because we have to write in multiple places. And so what MongoDB does is it has read-through, write-through memory caching built into the system. What that means is anytime you read a record in MongoDB, you're reading from memory. Anytime you write a record in MongoDB, you're writing to memory. MongoDB is smart enough that it buffers it and will persist it to the disk and make sure that it's durable with a journal and none of that data is lost. But as far as you're concerned, you're reading and writing right from memory. This is how operations are handled in MongoDB. And so not only have we leveraged memory to speed up our reads, we've also leveraged memory to speed up our writes. And so with MongoDB, you'll find that it's a magnitude faster than what you experience using SQL. And so you get this effortless scalability. Mongo is also horizontally scalable. You can just add more nodes to it. So as we look at the interaction of a MongoDB web app, our application programs in objects, and we persist those objects to MongoDB. And then we retrieve those objects to MongoDB. We no longer worry about 3 different schemas. When you're programming a web application with MongoDB as the backend, you're simply worrying about one schema, your application. And MongoDB is there to support you. And so in a nutshell, MongoDB is a high-performance, fully consistent, document-oriented, horizontally scalable database that enables agile and iterative development. Now, not to take my word for it, let's look at some companies that are using MongoDB in real life. First example here is Business Insider. They're a MongoDB PHP shop based in New York City, and they build one of the most popular blog or news sites on the internet today. What MongoDB lets them do is that they've never had any data migrations in the 4+ years that their site's been operating. They're able to store an entire article in a single record, including all of the tags, including all of the images associated with it. They store them all in a single record, and so when you the query to retrieve all the data you need to for a single view is a single, very simple, straightforward db.articles.find and find the one where the URL matches this URL. And it'll bring all the data for you in the format that their template language wants to handle it. So it's enabled them to not only do real-time statistics, but to have rapid development and growth. The second example is a company that most of us should be well familiar with, especially known in the United States. It's a company called Craigslist. And Craigslist is effectively the classified ads of the internet. They've been around for over 12 years. And over those 12 years, they've accumulated a large amount of data. And they've been using MySQL to handle all that data. And so what they had is they have their working set, and then they've got all of their archive data. And they got to the point where anytime they anytime they changed their schema, they'd have to change it not only in their working set, but in the archive data. The last time they tried to do this, it took over 2 months to run the alter table statement on the archive data. And they had set up for themselves internally that they were allowed to run alter tables once a quarter. And if you do the math, they're very rapidly approaching the limit of being able to run once a quarter. Also, when it's running the alter table statements, it's completely locked the database. So it was unavailable for 2/3 of the year. And so they started looking at how to solve this problem, and they realized that MongoDB could not only handle their flexible data needs, but also their large data needs. And so they shifted to MongoDB and have been extremely happy, never having to run that alter table again. The last example is e-commerce that I want to use here is e-commerce. And one of the big challenges with e-commerce is modeling of all these different catalog values. So things that are important to a camera, the important attributes of a camera, maybe lens size or sensor size, or if they have a flash or not, are going to be different from, let's say, a cell phone, where you're going to worry more about what bands it operates on. And so to model all those things in a relational way is a bit of a nightmare. And some companies have tried with moderate success, but no one's been real successful at doing it at scale. And so with OpenSky, they switched from a Magento-backed system over to MongoDB and experienced over 50 times performance improvement as a result of that shift. And we're able to eliminate memcache. And we find that's very common when people migrate from relational to MongoDB is they no longer need memcache, they experience a dramatic improvement in performance. So there's a lot of companies using MongoDB for a lot of things. It casts a wide net. There's lots of use cases that it's a good fit for. Not every use case, and we'll be the first at 10gen to help you know use cases that it's not good for. But for the most part, it fits a lot of use cases well, especially for web apps. And people keep coming up with new and brilliant ways to use it. And so you'd be in good company if you'd use MongoDB. There's thousands of companies using it in production today, big names like EA, GitHub, MTV, SAP, Pinterest, New York Times, Disney, and more. And so before we wrap up and I move on to the questions, I want to issue each of you on this call a challenge. And this is a personal challenge from me to you. I want to challenge you to improve your web development, make your lives better and simpler, make your applications faster and simpler by switching to MongoDB. And the challenge that I give you here is it's a new database, and it's scary because we're doing things new, and it's in a different way. And so what I challenge you to do is take a really simple project, something auxiliary, and commit yourselves to spend 2 weeks building a simple app in MongoDB. And what I can tell you from experience and from sharing this challenge with others is the first week's going to be rough. You're going to have a really hard time shaking the relational SQL ways of doing things, and you're going to feel a bit like a fish out of water. And that's a bit of the learning curve with MongoDB. The fortunate part is the learning curve is a little steep up front, but it's very short. And that by the end of your first week, you're going to start realizing that this is a really nice system, and it's going to save you a lot of time, and it's going to make your development a lot nicer. By the end of the second week, you're going to feel fairly proficient in MongoDB. You're going to be able to do a majority of the operations you're going to need to do to build a web app, and you're going to feel that it feels very natural to you. Now, of course, there's more to learn beyond that, but for most, I would say that 80% of your operations, you're going to feel very proficient. And this is, one, I think, of the great features of it is that the learning curve is fairly short to be able to be proficient in MongoDB. You can do it in a much shorter time than it took for you to learn SQL. And so that's the challenge. And I'd love you to share with me via Twitter or any other medium how the challenge went for you. And so now we'll open it up for questions. And I put up here my Twitter where I am everywhere. So I'm SPF13 on GitHub, on the web, on Twitter. And please feel free to share with me any feedback you have from taking that challenge or from this webinar. And I'm going to go through and I'm going to read these questions out loud. There's a bunch of questions that have come in. And so the first question here is, I have 2 fields, start date and end date. I need a query that shows me only records within those dates. How can I do it? And so the answer is it's pretty straightforward. What you're going to do here is you're going to use, in MongoDB, again, we're creating, as part of our query is really just an array. And so you're going to create an array with 2 elements. The first one is going to have a $greater than, and that's going to point to an array itself, and you're going to want to point that to start date as the key and 1 as the value. And this is saying I want to find anything here with start date. Oh, not 1 is the value. The value is going to be whatever the date is you want to show it that's greater than. And so you're going to say what you're trying to, in English, we'd read that and say, show me everything with a start date that's greater than, we'll say January 1st. Then you're going to put a comma, and in MongoDB, then you're going to put an and there, because you're going to want to make it say multiple things. We don't want an or here, we want an and. And so you're going to create an and. This will probably be easier to type than it is to describe, but I'm not sure if I type here if it gets pushed out to everybody. But what I might do actually is I might take all these questions and file and do a blog post answering each of them. And that way you can see, because it's fairly hard to describe without visuals what the code looks like. But in short, what you're going to do is you're going to create an array with an and as the top level key, and then that's going to have 2 elements inside of it. Each of them is one of them is a greater than with your start date, a less than with your end date, and that's how you're going to construct that. So effectively you're saying show me any document with both a date that's greater than our start date and a date that's also less than the end date, and that's what you would do with that one. I hope that was explained well enough. Let's move on to the next question here, and again I'll file up with a blog post so you can see the actual writing. It'll be on that website that's in front of you. Okay, next question here, and I'm just going the order they were received, is question that they had a challenge using MongoDB's MapReduce, and they find that it not as efficient as they would hope. In fact, it's easier to send the data to PHP and compile it themselves. And so to address this a little bit, MongoDB does support MapReduce, and it works reasonably well, but it's not the best. There's some definite limitations to it. And so in our response to that was we discovered that most people used MongoDB MapReduce to do aggregate functions, things like averages, max, and mins. And so what we've done is we've created an aggregation framework that's optimized simply for these aggregation requests, these aggregation queries. That's built in, it's streamlined, and it's coming in our newest version of the server 2.2. I'm not going to go too deep into the syntax of how the aggregation framework works, and there's lots of presentations on tengen.com that do, and they'll explain it in much more detail. But this is a way that you'll be able to process. His question is there a faster way to compile large data? He's at 200,000 records. And yeah, 200,000 records using the aggregation framework, depending on how many different computations you're doing on it, will be significantly faster than using MapReduce or moving it to PHP. And there's great examples. I recently gave a presentation about MongoDB and big data at Strata, which is an O'Reilly conference, and talking about how our aggregation framework works and how our connector to Hadoop works when you're dealing with truly large data. And so both of those presentations are good places, and you can find both of them on my blog. Okay, next question here is with a conventional, asked by Annie, with a conventional relational database, you use SQL to specify only the information you want returned from the query, which is useful in the databases on a remote server. With MongoDB, is there an issue with lots of data needing to be transferred? It goes to the next box, with lots of data transferred during queries. The answer is yes and no. Obviously, transferring more data over the network is going to take a little bit longer. But MongoDB, by default, it does return the entire document, but it doesn't need to. If you only need to get certain elements from that, the second parameter of find that we didn't talk about in any of the examples is which fields you want to return. And so you simply create an array talking about all the fields you want to return, and it'll only return those to you. You can also create an inverse array by setting those field values to -1, and it'll simply exclude those fields. So let's say I wanted a blog post, but I didn't want all the comments. And the comments, if there were a lot of them, might be a big part of that. I would simply set comments to -1 in that, and I'd get the blog post with everything minus the comments. And so it works very similar to SQL in this way. Okay, next question is, how would one go about documenting the structure/entities in MongoDB? What is the Javadoc equivalent? I'm not sure I fully understand the question, but in MongoDB, it in and of itself does not provide that. We think that's something that belongs in the user space. There are a bunch of PHP libraries. The book will highlight 5 of them that I've used and I think are good. One of the ones I've used a lot of is Doctrine, where you do that in the application with your application objects. And this is one of the things, even though you can do completely different schemas in every single record, that's not necessarily a best practice. That's not necessarily what you want to do. It's a great feature to have, and there's good reasons. For instance, when you're doing e-commerce and you're going to want to store cameras and phones, there's going to have some properties that are different from one to the other. But there are also going to be properties like price and SKU that are going to be the same. They're going to be consistent on every document. And so with MongoDB, it's often a good practice to create your objects in user space using a simple wrapper that either you write yourself or one of the existing ones like Doctrine, which define these for you. And Doctrine does support the document Javadoc equivalent of that, which is just the PHP's annotations. Okay, next question is, see. Do you in 10gen have different commands on core, driver, etc. development? Maybe it might be good to elaborate on this a little bit, but I'm not sure what you mean by different commands between the different things. I can tell you a little bit about 10gen. Internally, we have two different teams. We have a driver team and a core team, and the two of them collaborate often on anything. There's not a lot of commands that differ between them, but the drivers operate on a much lower level, and they expose it in a more elegant interface to the programming language that they support. And so if you're looking for more information of how the server itself actually works, there's documentation about what's called the wire protocol in MongoDB, and you can find that on mongodb.org in our documentation section, which outlines how the drivers talk to the server. And hopefully that answers that question. Okay, next question. This is a great question here. It says, can you please talk briefly about backups, moving data, and hopefully horizontal scaling? And yeah, I'll talk about that briefly. And so I'll talk about two things that I haven't really highlighted here. I'm also looking at the clock, and we're starting to run pretty close to 1 o'clock, or 2 o'clock rather, in New York City time, meaning the end of our webinar. I'm happy to keep answering questions for a few minutes beyond, as long as the good people at O'Reilly are happy to let me, and of course all of you are welcome to drop off anytime you want. I will be trying to comprise these into a blog post, hopefully provide a little bit more information and links to external resources that will help answer those even better. And so, yeah, so for us, what the way MongoDB works as two different ways, and this is there are some other NoSQL databases that combine the notion of replicating data for high availability and sharding or partitioning data for horizontal scale. In MongoDB, we treat those as two separate things. And so the first thing is we've got replica sets. And a replica set is I like to call an evolved master-slave. And the reason it's evolved is because it's aware. The replica set, it's comprised of 3 or more nodes, each of which are aware of the other nodes in the replica set. And they do nice things of, one of them will be the primary, which is analogous to the master, and the others will act as secondaries, or same as slaves. And the reason we changed the terminology is because they are a bit different. And the big difference here is that for every one of those nodes is aware of the other nodes, and they're aware that there's only 3 of them in a set with 3. And so what they have the ability to do is, let's say the primary failed for whatever reason. The secondaries, the 2 remaining secondaries, would communicate with each other, notice that they can't communicate with the primary, would say that since they're 2 of 3, they can establish a majority, and one of them would be elected as the new primary. Now the former primary will then be relegated to secondary status and put in recovery mode once it reconnects, or once it joins the set again. And it'll be automatically in recovery mode until it catches up and has all the data, at which point it'll remain a secondary but continue to at that point start taking reads. So it's in recovery mode, it doesn't take reads until it's caught up. Once it's caught up, it'll take reads, and it'll just operate like any of the other nodes, but now as a secondary. And the node that began as a secondary but became the primary will continue until there's another election event, which will be triggered by something like a machine going down. And so part of the one for high availability, which is not part of the question directly, but backups is a good indicator, a good way to do. High availability is a good way to do some backups. You can use these replica sets. You can also do backups directly from a machine, whether that's a secondary or primary, by doing things like MongoDump, or simply taking a snapshot of the files on disk. And MongoDB works equally well with either of those. So MongoDump it simply dumps it out to a JSON document, of which you can import using Mongo Restore, or you can just take a snapshot of the files on disk and the files on disk are all in the same directory, which is configured in your MongoDB configuration, and so it's really easy to snapshot. If you're using something like XFS, ZFS, or EBS, which all support snapshotting. Now we'll talk a little bit about how we approach scaling data in a horizontal way. And MongoDB has shard support natively built into the server. And so what this does is this lets you go with a single node where all the data resides and split that into two nodes, each containing approximately half of the data, or 10 nodes, each containing a tenth of the data, or thousands of nodes, each containing a sliver of the data. And what this does is it gives you better write performance, as the writes are now distributed across, each node is only taking a very small portion of the writes, and it lets you have better read performance, as each node can power only has to handle a portion of the reads. Now, these two different approaches are also stackable. So if you want a highly available system that also has horizontally scaled, what you would do is you would create a bunch of replica sets that each would operate as a single shard inside of the Mongo cluster. And let's see, what else to talk about this? So one of the nice features about MongoDB is you're able to start small, let's say with a single replica set. I always recommend replica sets in production because highly available things are good. Highly available is a good thing for a database. So you can start with a single replica set, and once you grow to the point where you need to switch to a shard, and I would say probably a little before you need to switch to a shard or a sharded clustered system, you should do so. And you can do this in MongoDB with no downtime whatsoever. So MongoDB is the only product that I'm aware of on the market that lets you switch from a single node to a clustered, sharded system with no downtime. It does it completely on the fly. It's a great feature. And what it does is, when you do that, part of the question was asking about moving data. When you do that, the Mongo cluster will automatically begin to distribute a portion of that data from the primary server onto from the original shard onto the now newly added shard. And you can do this forever. You can continue to add shards. Each time you add a new shard, a chunk of the data will move. Some chunks of the data will move to this new shard, and MongoDB automatically takes care of automatically balancing and distributing the data. It takes care of automatically routing all of the queries that you're doing and automatically routing all the saves and updates that you do. And so the nice thing is you can also shift from a regular node to a completely sharded cluster without changing your application at all. And so your application, you queries it the exact same way, you write updates the exact same way, and the Mongo system takes care of everything for you. So you write your application as if it needs to scale, and MongoDB just makes sure that it can. Okay, the next question in here is, the question is, along those same lines, it must be of something I said earlier, do you think ORMs like SQL Alchemy, the Django stuff, there is a way to patch on MongoDB's functionality to SQL DBs? I'm not sure I fully understand that question, but I'll answer it the best I can. The way I'm seeing you're asking this question, I see that ORMs tried to do what MongoDB is doing, is they tried to find a way to map objects to a data store, and to do it in a way that's very convenient to the programmer. And in of itself, that's a noble thing to do. The only problem is the way they went about it brought on some undesirable consequences. And there's lots of posts exposing the dangers of ORMs, and that it's very easy for an ORM to to generate bad queries and take down your database. It's easy there's lots of nice features. They centralize things. They provide validation, a nice interface. Another big problem with most ORMs is that they neuter SQL. they only have a very limited amount of the full flexibility and power of SQL that they can actually do. For instance, I don't know any ORMs that gracefully handle large transactions, SQL transactions. Oh, that's one of the nicest features of SQL. And most of the ORMs struggle horribly with things like aggregation, which SQL does a great job with these like averages and group bys. And so the ORMs have taken a lot of the power out of SQL, and they bring along with them a lot of overhead. Every ORM is always heavy-handed. And then they also often generate suboptimal queries, unless you're doing very simple queries. And so with MongoDB, I think it's approaching the same problem, but approaching it a fundamentally different way by changing the entire data store and then providing that elegant interface. If the question is there an easy way to interoperate with things like Django? I'll talk about the Doctrine project. Doctrine is an ORM, but it also supports a MongoDB document layer called an ODM. And one of the nice things about Doctrine is it makes it very easy to do a hybrid system where part of a lot of people when they're transitioning to a MongoDB system, they already have a SQL system. And so with Doctrine, it's really easy to use the same objects that are storing to SQL that you'll also be able to store and persist those and read from in MongoDB. And again, I gave a good presentation. I think it's a good presentation. I've heard good feedback on it. Presentation on doing hybrid applications. And that presentation, again, is on my blog. And I'll link to it in the blog post that I'll write as a follow-up to this. Okay, next question is MongoDB not just a persistent JSON engine? And I will say MongoDB is not just a persistent JSON engine for a lot of reasons. One is that MongoDB doesn't actually use JSON. MongoDB uses a binary format that makes traversal and searching very fast, whereas JSON itself would need to be decoded by the system every time it iterate over it. VSON doesn't. It's a format that's natively understood by MongoDB. It's a spec that's out there and open. It's at bsonspec.org. And so what MongoDB is, I'd like to think of it, it's really a document database. And what it does is each of those drivers natively, what they do is they translate the BSON into native data structures. And so in PHP, you always are working with PHP. It feels like PHP. You're using regular PHP data structures. In Python, you're using Python data structures. In Node, you're actually using JSON. But in Java, you're using Java data structures, C#, etc. And so MongoDB is really, thanks to the drivers that make it so that MongoDB feels like a native, interaction feels like a native application. It feels like it's part of your programming language, and you don't have to program in JSON or anything else. It just natively understands those. Okay. Next question is MongoDB supported in Zen framework? The answer is a mixed yes, and we're working on it. We've recently actually hired a programmer tasked with the job of improving the support in Zen framework. But the answer is Zen framework is very pluggable. It's very easy to use MongoDB in it. And we're working on things like adding support for it with like Zenlog. So that Zenlog has a MongoDB backend. And that's a great thing for MongoDB. MongoDB is, with its read-through-write-through memory caching, it can handle a ton of concurrent requests at a very fast pace. So it's great for something like logging. And so the answer is yes, it's supported to some degree, and we're improving it. And we're working very hard to make that support better. Okay, I'm going to go through, just looking at the time, I'm going to go through and I'm going to take, there's about, 20 more questions in the queue here. So I'm going to take as many as I can in the next 5 minutes, and then we're going to wrap up. And again, you can turn to the blog post that I'll follow up with. It'll probably be a couple days because there are so many questions before the post goes live. And it'll answer all the questions that have been asked and provide hopefully more detail on them, as well as references, links to places that will help you with the answer. So the question, here's a question here. It says, if some people use the word author and some people use the word writer as a field name, is there a way to treat them as synonyms? And the answer is no, and kind of. In MongoDB, it doesn't support synonyms, but it does support an or. And so you're able to say, show me anything where author or writer equals Steve. And it'll work seamlessly in that way. But it obviously, so MongoDB has support for the or, which will let you write queries that would support this, but it doesn't have native synonym support. And so this is actually highlight, though, let's say you're doing a migration and you're trying to switch. It used to be author, someone decided that writer is a better term, it more accurately describes it, and you want to switch. Now there's two different ways you can do this. One is you change your query to handle either, and then whenever you write one, you could lazily change it on the fly, or you could simply write a command that goes through and just changes your entire database. You'd still write the query with an or in it, so that anyone, because you don't want any downtime, so if anyone comes to your application while that script is running, they'd still be able to have the results returned without any downtime. And then the next time you deploy your code, you'd remove that or in there and only query the new field. Okay, next question that we have here is, sorry, just bringing it up in the screen. Okay. So question here, I'm not sure if I fully understand it, but the question is, updates are very expensive. I don't know where we get this claim from, but in NoSQL, updates are very expensive in NoSQL. Is it not better to replicate and create new objects of merged data in another collection? Updates are not very expensive in NoSQL, at least not in MongoDB. They're more expensive in some of the other NoSQLs, because what they have to do is they effectively don't update. They create a completely new record and delete the old record. But for MongoDB, it can do updates in line, and that is a very efficient thing. It modifies a small amount on disk. It's a very fast thing. You have to transfer a very small amount of what you're actually changing. So you don't have to, for instance, if you had a blog post with 1,000 comments on it, the update only is passing along the new comment. You're not retrieving the entire old blog post, modifying it, and saving the 1,001 comments. You're just passing along a new single comment, and it just writes that single comment in disk. Generally, it's a very fast operation. And the question is it better replicate and create new objects of merged data in another collection? I don't think so. I've never seen anyone do what you're describing here. But to highlight again, MongoDB updates are very fast. And again, when the data is in memory, which is a point of MongoDB is rarely, if ever, CPU heavy. MongoDB highly benefits from memory, and so if you're working data sets in memory, MongoDB will be extremely fast for you. If your working data set doesn't fit in memory, MongoDB in most circumstances will still be faster than SQL, but it'll feel a magnitude slower than when all of your working data is in memory. And so it's kind of the difference between Memcache and SQL, right? If your data is in memory or not. Again, it's generally better performance across the board than SQL, but significantly better performance when the data is in memory. Okay. I think there's a question here about a mistake in my slides. I'm gonna skip that one. It mentions that the date was a Mongo date and now it shows a string. That's just a mistake in my slides. It should always be a Mongo date. I'm going to go through and fix my slides. But to talk a little about Mongo date, Mongo dates are native format to be able to, across all the different languages, store a single date format that just works. And so each driver creates this Mongo date object inside of the language. And MongoDate has some nice properties to it, and it's convertible to a timestamp by just calling the timestamp method off the MongoDate object. And so the next question here asks about Node.js. And it says, these days I hear that Node.js is good for scalability. So is it really true? With PHP we can't scale well? I think that's a misstatement here. I think if you look at a lot of big companies have scaled very far with PHP. I'm going to echo something that you might have heard before, in that in most applications it's not your programming layer that's the scaling bottleneck. It's almost always your data layer. And that's one reason why MongoDB is such a great fit. Another reason is your PHP applications will actually run faster with MongoDB because they'll be, in general, doing less work. Most people find when they migrate to MongoDB, their application, they end up throwing out, a significant portion, sometimes 30 to 50% of their code, because the interface for MongoDB is so much simpler than what they had been experiencing to interface with their SQL. As the slides demonstrated, quickly your application will be talking in 3 different schemas, whereas MongoDB it's one. And simply that in of itself is just reducing so much of the workload on the application servers. It helps them scale. But many companies have already proven that PHP scales well, and other companies. And if you look at the top 20 sites in the world, more of them are on PHP than any other language. Maybe Java is the exception to that, but those are the 2 most popular ones. You won't find any that are running Ruby or Node or Python yet. They're mostly either written in C, like Google, or Java, which Google is also made up of, or PHP, like Wikipedia is. So I think that's a misnomer to think that PHP can't scale well. Okay, and looking at the time, I think we're going to wrap up. I'm going to go ahead and take all of these comments or questions that have come in and start working on a blog post for them. But I want to thank you all for tuning in today for this webinar. It was a pleasure to talk to all of you, and just again to highlight that MongoDB is the product produced by Tengen, which is the company I work for. My role there is managing the drivers and integrations team. We offer commercial support and services and training around MongoDB, and it's a lot of companies, when they're switching to it, like to have a little bit of an insurance that someone can help them keep the lights on and help them when they have issues or questions. MongoDB support is from someone who's been a CTO a number of times and has signed a bunch of support contracts. Is a real bargain. It's a very small cost per server, and we've recently rolled out a new plan that if you have a development team that's new to MongoDB but you haven't shipped yet, because support's for servers in production, we have a new product where we offer support and training and answering questions for your team as you learn MongoDB. And that's the commercial aspect. And we also provide tons of resources from our conferences, which we have over 30 conferences throughout the world, to books, which are a lot of books published by O'Reilly, to our documentation and examples on our website, to our Google groups where you can ask any question you want. And we're very active on Twitter. And our primary objective on Tengen is to really get you to use MongoDB and to love it. And we think if you love it, that you'll use it and enjoy it and tell your friends about it. And some of those friends will work for big companies that want to pay us. But for the most part, our objective is to help you and to make sure that you understand and learn MongoDB and use it, and that's a good fit for you. And we're very pragmatic people, and more than once I've told someone that MongoDB is not a good fit for their use case. They should use a key value store. They should use a relational database because it's a better fit. So that's the kind of people that we are at Tengen, is that we're very pragmatic, and the last thing we want you to have is a bad experience by trying to fit a square peg in a round hole. So if MongoDB is not designed to do what you want it to do, then if you have questions about if it would be a good fit, just ask us, and we'll be very honest with you. And we'd much rather dissuade you from making a mistake now than create someone who's has a bad experience with MongoDB and it does no one any good. So thank you all, and I'm Steve Francia, and it was a pleasure having this webinar with you.